Compression testing is oftentimes needed to determine an engine's mechanical health. On today's vehicles, it's getting increasingly difficult to access all cylinders when a compression test is needed. In this video, I'm going to show you how to perform a relative compression test. This test measures the current draw of the starter motor as it rotates the engine during cranking. Using a lab scope, we can compare relative compression on all cylinders using battery current draw. Typical current draw of a 4-cylinder engine is about 200 amps, 50 amps per cylinder, with peaks up to 500 amps. When diagnosing, a 10 to 20% difference would indicate a problem cylinder. Now keep in mind, this test only shows relative compression. So if you have a batch of weak cylinders, you may not be able to detect the fault, as they could display the same current draw at a lower than normal value. Begin by disabling the fuel system. In this example, we disconnected the fuel injectors. Crank the engine until it stalls. This will remove any excess fuel. Remember to clear any fault codes when done. Make sure the battery is fully charged during this test. To test, you'll need a multi-channel lab scope and a current probe. Before testing this 2017 V60 with a misfire and suspected base engine issue, let's review a good waveform so we know what we're looking for when identifying a problem engine. Using our cylinder 1 mark, we can identify all 4 cylinders using the firing order. Normally, we would want all cylinders to be about the same, as shown in this waveform. All current peaks are about the same. This is a good test result. Now back to our problem Volvo. Connect channel 1 to cylinder 1 ignition coil or injector trigger. This will help us locate cylinder 1 and the remaining cylinders in the firing order. Connect an amp probe to channel 2. My probe is set to 20 amp, which will display 100 millivolts per amp. The probe is connected to the starter positive cable. Set the scope to record engine cranking. With my scope, I simply use the deep record function. No need to set triggers or voltage time base. Crank the engine for 5 seconds. Let's review the capture. I will zoom in on 8 compression cycles. Let's mark cylinder 1. Using the firing order, we now know the rest of the cylinders are 3, 4, and then 2. With the cylinders marked, I'd like to turn off my ignition pattern. You can see the low peak on cylinder 2. This is a low compression result. Let's zoom in for a closer look. You can see the difference here is about 0.5 amps or 10% of the other cylinders. Also note the higher peak on cylinder 1 due to cylinder acceleration. With this information, we can now dive deeper and perform a cylinder leak down test to determine the location of the compression loss. Thanks for watching. See you next time.